Welcome to the lecture series on object oriented analysis and design. So, we have looked at non UML models playing a wonderful role before we get into the UML, Unified Modeling Language, and through that the object oriented analysis and design and so on, as we have discussed. The way in which we deal with data improved vastly with entity relationship models, not necessarily because they are very easy, they are only tables, charts which we talk about the dynamic behavior, but it has a theory behind it. There is a relational calculus, there is a tuple calculus. So, we know for sure that this is what will happen. If you are in adherence to this entity relationship model, even though prima facie it appears as all too familiar tables, joins and all that, there is a calculus that drives those tables, and therefore, we are very confident that if it is in adherence to this, whatever is coming out is correct. It is like that, only that can come out. So, there is a mathematical basis that tells us that yes, it is correct, what is retrieved is verifiable in the sense what we have been talking about. So, the notion of verification and validation permeates through all these things. It is not that simply by using non UML models we can escape verification and validation. No, we will get more into the verification and validation. UML is a nice lingua franca today for whatever we are doing as object oriented analysis and design. The overall objective of V&V approaches is to ensure that the project is free from failures and meets its user expectations. Please note ensure. What is the philosophy of insurance? Even now we are talking about it, there are certain what is it called corona special insurance models, insurance schemes that tell that today you please pay, somebody is in the age group of so and so and inflicted only by these known diseases, you please pay so much. It goes on and on and on for some years, for so many years you have to pay that, and in case in the middle of this, if you are afflicted by what you are insured against, then the company will pay you so much. If nothing happens, you will get your money back with some higher interest rate and you get tax exemptions. So, life insurance is a nice idea, we can debate. We always have lot of debates on it. Is the insured value reflecting whatever it is for any given person? All these things are very well known queries, and we have wonderful and stable expertise in all these areas. The overall objective of V&V approaches is to ensure. Now, where is the question coming? Software today is impacting life. It is not merely improving quality of life. So, there have been wonderful works, wonderful papers, lot of deliberations on what is it that we can do on insurance. Can we talk about software insurance? All these topics are there. However, the number one problem which we are facing is the 60-year-old challenge of verification and validation, because none of these terminologies are the generic sense of using the terminology. There is no way in which I can tell the product or the project is free of errors. It is still there, only 33% is tested. How can I tell that by doing 33% rigorously, I will attest that the remaining 67% is also correct? It cannot happen, because that is also a piece of software. All tools are pieces of software, not done by us. We believe that it is a good organization that has done, it goes by whatever they have said. It is possible to do. People have affixed their brands, people have withstood all the implications of being in a profession which is just 40 to 50 years young, calling themselves software engineering and welcoming the comparison with other harder engineering disciplines as well. So, correctness is that the product is free of errors. Consistency, the product is consistent within itself and other related problems. Necessity, everything in the product is necessary. How do we know what is that necessity? Because we only test 33% and 10 people have said yes, it is doing everything, because each one did 10 things and said most of it is happening well, therefore, everything is necessary. Sufficiency, the product is complete. Quality, the products are, it is not that we are pessimistic about what is happening, this is how it works. That is the very nature of software engineering that is moving mountains today. If today we have been easy on these past 6 months, it is because of the challenge which the environment withstood on technology. What is the prominent technology? Most dominant technology is not automobiles, not anything. It is just plain simple internet, online tools and working with that. It may be an undercurrent in the way different professions have jumped in, the medical profession of course, we should thank them for jumping in, and of course the security, two things, all of them are driven by the software, and that is how we planned. It should be sublime. The technology of software should be sublime because of all these reasons. It is not likely to be the most dominant. For some spell, good spell it was very dominant, but as we progress it becomes sublime in other disciplines. That is what we think. Correctness, consistency, necessity, sufficiency, quality. The product satisfies its quality requirements. By saying so, what is the implication? You made a claim like this, whether it is internal or developers or external, we are only attesting that for the claim that you have made and a process and a method which you have specified, you are likely to get to 75% achievement in terms of everything that you have envisaged. Attainment, it is called attainment. We can find out what is the attainment level. It makes a lot of sense, because once you say that the third party is welcome, it is something which people can analyze independently of where it happened, which is a great plus in that exercise. Verification and validation, are we building the right system? Does the problem system, the problem statement accurately capture the real problem? Did we account? Is it what the stakeholders were looking at it, needing? Are we building the system right? Does our design meet the specification? Are our requirement models consistent with one another? All these are difficult questions. I have explained it in a simple manner. Verification is what we are doing, which facilitates a third party. Validation is something which tells that is it what that the end user or the stakeholder was looking for. Very difficult to satisfy all multiple stakeholders coming from different domains, but then we have strived to keep this as one of the finest challenges. While you are right from step 1, right from the time when you are choosing your life cycle, right from the time when you are defining your phases, you cannot escape the idea of verification and validation. Verification is more about the developer side, validation is more about the business side. Once again, we take recourse to the fact that the business side approach is greatly enhanced by the object oriented analysis and design and chiefly use cases. So, it has become like that, the problem situation, verification and validation. The inquiry cycle, there is a prior knowledge, there is a need to observe what is wrong with the current system, intervene, replace the old system, design, invent a better system. No system is perfect. Even during the days when software was not at all known, not at all there, people were talking about this idea. Something is not fitting. If we do something like that, maybe everything will become better. We have been talking about the industrial revolution that has thrown out at a very quick pace so many things that facilitate what is called an unthinkable mass production. Suddenly you cannot scale with so many pieces of demanding pieces, but then we did it, and it is like that, wrong things. The industrial revolution was there. Intervene, replace the old systems, we have always been talking about it. Model, describe, explain the observed problems. Similarity with process of scientific investigation, it is quite scientific. We should know how to inquire, and most of the times what we end up is not necessarily because of the prior knowledge, because the developer simply goes in to the customer and they start explaining based on what they perceive, what they observe. This is going to be the typical start for any development exercise in the field of software engineering. Look for anomalies, we talk, we discuss. We are not likely to go and find out what is the knowledge from various aspects. Whoever can observe and document is good enough, we will get started with that. Now, into this we brought in the domain knowledge, the necessity for domain knowledge. Then we start moving towards scientific investigation. It was very dominant. The idea of domain knowledge punctuates many scientific explorations. So, the terms science, engineering in our context have also been tailored to what we aimed at, that is a sort of machinization which is different. It banks, it draws on the best faculty of human being, namely the brain. So, other engineering exercise not so much on that, but here it is, it tries to mimic, it tries to get there. Model, describe, explain the observed problems. So, once we start talking about in the domain, not the developer's domain, but the stakeholders domain, then we start talking about scientific investigation, something like this, what we have been talking about recently. Every talk, everywhere we talk, each speaker whom we hear will touch upon this idea called the global crisis, the pandemic crisis. This is no different. Whom do we consult? The medical experts. Where is the domain? Medical domain. We can talk about everything as supportive of that domain. Today, the most dominant domain remains medical domain. No second opinion about it. It's like that, it's a crisis on health. So, we need that. The domain is very clear. How many people have this domain knowledge? Well, questions we try to address, not now, for centuries. The same questions, the same problems. To some extent, we are able to put together a methodology by which we can address very squarely based on observations, based on interventions, talking about designs and talking about models with some inputs from the domain experts, a way of telling that there is a sense of addressing these concerns of verification and validation, which should begin on paper like this. Right at step 1, this should be obvious, otherwise we are not likely to progress in the direction of verification and validation, which is all important. We cannot simply tell that we had 1 year time, whatever happened after 1 year is what we started with. How much ever we talk about a precondition, post condition, we still need to understand that there is a need for establishing what will eventually at the end of the day be called verified and validated. Towards that, right at step 1, we need to put all these things in place. We need to facilitate verification and validation that will happen at some point in time. Life cycle designs have been chosen on what kind of an emphasis we need to have on verification and validation. So, there is an application domain, there is a machine domain. We are not really talking about the domain as knowledge domain. We are talking about an application domain which is tailoring that domain to what we need. So, in theory, I can be happy doing what is called, let us say, computerized eye testing without becoming an ophthalmologist with an experience of 20 years and expertise of 40 years. May not happen. The kind of domain knowledge necessary for doing this computerized eye testing is all that I am able to pull out or cull out and then go ahead and try to machinize. So, that translates into requirements. Even though it is called computerized eye testing, it is not a full tested ophthalmology kind of an exercise. It is just that is necessary to convert it into requirements from where we can address how to take forward to the machine based on whatever we have been talking about. Domain properties, things in the application domain that are true anyway. So, most of the times we talk about facts. The logic programming paradigm based on which we were talking about expert systems are facts. Talk about fact, domain properties, requirements, things in the application domain that we wish to be made true. Specification, a description of the behaviors of the program must have order to meet the requirements. So, the requirements phase we have understood. What does the specification tell? If and when all these requirements do become the piece of software, how do I know that they are in tune with the requirements? How does it behave? Whether we like it or not, this term behavior did get positioned in the specification, that software should behave like this in tune with what we required. So, this is where we have been talking about all common jokes. We keep telling that we tend to become so deterministic in the way in which we are talking, that even if we think of Rama, Rama must be like this. And at the end of the day, we find that we were not looking for Rama, but we were looking for Krishna. This can happen. So, requirements, specification, the way the entire piece of software, the artifact behaves is all there. The program must have, in order to meet the requirements, two verification criteria. The program running on a particular computer satisfies the specification given the domain property satisfies the requirements. There must be a very nice way of verification. Very quickly we should be able to see, and that is where object oriented scores, because it translates everything as what is called the data and the operation indicating the behavior the moment they are put together. The moment you put the data and the methods together, make it an object, the identity and its behavior become obvious. So, we think it scores well. Two validation criteria: did we discover all important requirements when it eventually came? Did we track, did we find 10 people doing 10 things, which will address whether we required all the things or not? Did we discover and understand all the relevant domain properties? Relevance, relevancy, important requirements. 100% is a dream. Usually we start saying that we will do so many things, we are likely to end up doing 30% and add 30% more as additional gold plating, frills which we talk about. The domain properties, that is how we have been talking about. Requirement: reverse thrust shall only be enabled when the aircraft is moving on the runway. When it is not on the runway, this is not necessary, but then it is still there in the aircraft. It should be still there, that mechanism is still there in the aircraft. Just because it is not on the runway, it does not mean it is not there, because eventually it will be on the runway. Somewhere it will be there on the runway. Domain properties: wheel pulses on if and only if wheels are turning, wheels turning if and only if moving on the runway. So, there is a requirement R, there is a domain property D. These are some symbolic specifications. Anytime we should be able to address like this. Validation: are our assumptions D about the domain correct? Did we miss any? Are the requirements R? Tomorrow we will tell R1, R2, R3, D1, D2, D3, S1, S2, S3. Verification: there is a flight software P running the aircraft. Why is it happening like this? It is essential to talk about an abstraction. Now, what is happening in the field of software development most of the times is we simply do not have the time to recast our requirements like this, which will make it amenable for a mathematical analysis. The same algebra, the same abstraction that makes us build things faster. Even if there are 20,000 requirements, R1, R2, R3 are 20,000, this kind of a way of capturing those requirements to enable very quick verification and validation is essential. So, we talk about the same mathematics, talk about the same algebra, talk about the same theorem proving. It helps, it greatly helps. However, who has the time to cast it in this manner? Capturing requirements itself is taking a lot of time, but then we have to do it. And how do we know that whether we have done this and behavior also mapped properly? We have a way of doing things: reviews, walkthroughs, inspections, software testing, not applicable to requirements engineering. So, we have been telling that some essence of software testing must happen. We are not testing the requirements, but they should be in a manner where we get an idea about at least a few types of software testing which will have to be done. Formal methods: this is what was the game, this is what we wanted to aim at. Use mathematics to prove that requirement. There is nothing like QED at the end of the day, still proving to be elusive. We have been trying, but then proving to be very elusive. Consistency checking: verifying consistency between models, prototyping, present a prototype to the stakeholder to confirm that it has the expected behavior, requirements tracing, traceability. This is what I was talking about in one of the lectures. As we keep doing this business driven, traceability should go up. It is a two-way traceability coming from top down and going from bottom up. V&V activities, reviews, talk about lot of reviews, inspections, a process management tool, it is a FAGAN tool, it is an inspection tool, software inspection. Lot of books were there. For several years we have been talking about, very expensive at that time. Software inspection was not so much popular even in academic institutions. The quality assurance people had a way of working, however they were expected to do the software inspection, and it is a different model. We are not looking at what is called looking at every line of code. By inspection we should be able to tell. This idea of doing by inspection is the quintessence of engineering. We do not need so much of tooling, we do not need so much of that skill, that expertise is like that. Simply by looking at it I can tell that this is what it is, and that has greatly enhanced the virtue and the value of what we do on the field. Should be able to tell by inspection. People have been taught, if you take a brick, the mason will tell no, this is not, something faulty about it. Talk about a scooter mechanic, we had a very good scooter mechanic close by. The moment he listens to the sound, he will tell what is the problem. I have seen you going like this, the sound is not so much. By inspection, we do not do so much of checking, cross checking, 300 cross checkings, that is not the idea. It is not the idea. We should move towards what is called software inspection, but then it is proving to be elusive. Line by line analysis is more a walkthrough, that is what is the next step. Developer technique used by development teams. The inspection is, if you can make a piece of software that is amenable for inspection using a tool like FAGAN or whatever it is, anybody, even non-programmers can come and tell. That expertise is that domain person should get a feel for what is happening at the earliest. However, most of the times the quality assurance people would want a walkthrough. Yeah, this is what it is, line by line checking, cross checking everything, critical functionalities used by development teams. The idea of walkthrough is more in the developer space. The idea of inspection can be anywhere. So, the goal was inspection, plenty of textbooks came, but then we are still not able to do that. And when we said there is something called a software engineering body of knowledge, we felt that it should be possible to do it like that. The field work is greatly enhanced, get a feel for it. That is why it was a craft. Even today most people argue that engineering is best when it is in a craft form. Well, I teach engineering, I come from a very good reputed engineering school. So, we keep telling that no, engineering is something which is a profession, it is done in a professional manner, but then it is still at the foundation has its bearings in the craft, in the way in which it happens as a craft. Management reviews, preliminary design review used to provide confidence that the requirements are sound. Well, this is the next step, management review. Usually we are like this: first review, second review, third review. We are most of the times in this space, in this method. So, 3 reviews, 4 reviews, 5 reviews, one more meeting. It is not that we are contradicting that method, this is more difficult. So, beyond 2 to 3 rounds of meetings, we would rather go ahead and bank on the walkthrough, take it into the developer space. We do not have the time, we do not have the money to do this over and over again ad infinitum. Therefore, we go ahead with the code and bank into the developer space, because they are the people who are telling that we know how to translate all this into the code, let us bank more on the walkthroughs. The flip side of that I have already discussed in the earlier lectures, the software requirement specifications with stakeholders to validate. This becomes very difficult. Early stakeholder input, early stakeholder confirmation, they become very difficult because neither they are clear nor we are clear most of the times. and therefore, at some point in time, at a convenient point in time, we will halt reviewing, move into the developer space. At a time when the code becomes reasonably obvious, we will start doing the walkthroughs. This is how we have been doing. What is the problem with this? The problem is the business requirements are very stringent. There is only given time, given budget. Within the given time, within the accepted budget, we should be able to do that. When they become very strict on these two parameters, today the best of the success stories are just around 36%. We should be humble enough to acknowledge that. What are the formal methods? Model analysis. This is how it's happening in practice. This is what I described as practice, which is review centric, very review oriented. We wish that there are formal methods, they are very elusive. A good model, formal challenges. If the model is correct, then the following property should hold. What if questions? It was very famous because of the spreadsheet culture. It was very good. Most project managers simply start asking those what if questions for quite some time. For a good spell of time, I do remember that talking to management teams was very easy on what if questions, reasoning about consequences of particular requirement, and this was greatly facilitated by a tool which is any tool that resembles like an Excel. You change this parameter, what will happen? It will tell all the formulae are built in. The spreadsheet, anything that resembles a spreadsheet was deemed very essential, and it was a very common question, very common approach. That is when you are beginning to talk management, not the review, but the management per se. And once again we said software project management should be distinguished from many other things. There are very good reasons. Is the model well formed? Is well formedness enough? If the model is looking good, is it correct? These are the concerns that we have been talking about. State exploration, use a model checking to find traces. Model, that itself is a challenge. We know, because object identification and modeling is still remaining as a very big challenge, and until we do that model design and arrive at design verification, the formalism is elusive. So, once again we tell that while all these are nicely facilitated by UML, we still have to bank on the methods of reviews, V&V activities. We do this very often, and then we like to go to this faster. The ideal is software inspection. That is summary of this lecture. So, how do we review the software requirement specification with this perspective and paving way for this to happen? That is the challenge, first challenge we have. And whatever you talk about use cases, whatever you talk about requirements driven, whatever you talk about business driven, this remains a very big challenge. Thank you. We will meet again in the next lecture.
Thank you.